Hi, this is Gus Nelson making my video for Math 151 about the unit circle, and this is going to be divided into 6 parts. First, review of the unit circle, then repetition pattern 1, then re-examining the unit circle, then sine mountain, then repetition pattern 2, then cosine valley. So repetition patterns 1 and 2 are not going to be tips and tricks. They're going to be animation sequences of certain values across the unit circle backed by music going to the beat to help you associate where certain values are placed on the unit circle. So here is a unit circle that I have drawn, and you'll notice there's 3 sets of measurements taken on here. There is the degrees, the radians, and then the sine values of these angles. And what's really important to note is that these sine values I have put are just the magnitude. They do not tell you whether the value is positive or negative. So for example, here we have this root 1 over 2 and all these below the x-axis. These will all be negative values. And now what I've done to the unit circle is just draw in the different quadrants. Just remember that this is xy, this is negative x, y, this is negative x, negative y, and this is x, negative y. And so we're going to do the first repetition pattern, and it's just going to be a unit circle demarcated in 15 degrees, but only one angle will show at a time, and it's going to go in a counterclockwise direction to the beat of a song that'll play. It's 1 minute long, and I hope you enjoy it, and it's going to start in 3, 2, 1. Welcome back. I hope you enjoyed the repeating pattern. Now we're going to get into re-examining the unit circle, and we're going to look at a pattern that emerges with similar reference angles. So first we're going to look at the angles that have a reference angle of 30. And I see I've marked here in black are the angles themselves, 30, 150, 210, and 330. And those are made relative to the positive x-axis. But if you include the negative x-axis, then you see 4 sets of 30-degree angles. And the question is, how many units of 30 does it take to get from one angle to the next? And here's what happens. If you start doing it by 30 degrees, well, you find it takes 4 sets of 30 to get to the first angle to the second. It only takes 2 jumps of 30 degrees to get to the next reference angle, which is 210. To get to 330, you find it takes 4 jumps. And then to return back to the first reference angle, it takes 2. So you see this pattern of 4, 2, 4, 2 emerges. So now we're looking at the 45-degree reference angles, and that's made by 45, 135, 225, and 315. Again, the black is the actual angle respective to the positive x-axis, and the blue lines indicate the reference angles created by positive and negative x-axis. And so we notice here is it takes 2 sets of 45 to get from 1 to 2. It takes another 2 sets of 45 to get from 135 to 225, and the same thing to get back to 45. So all around, we see an emerging pattern of just 2, 2, 2, 2. And here we are looking at the 60-degree reference angles made by 60, 120, 240, and 300. And here we notice something similar but opposite of the 30-degree. From this first 60 degrees, it's going to take just 1 step of 60 to get to the next one. But then after that, it's going to take 2 steps of 60s to get to the next one. But then after that, it's only going to take 1 step to get to the next one. But to return all the way back to the first reference angle, it's going to take 1, 2 steps. So here what we see emerges is a pattern of 1, 2, 1, 2. And we're going to come back to these later on. But just remember, for now, for 30-degree angles, we see a pattern of 4, 2, 4, 2. For 45 degrees, we see 2, 2, 2, 2. And for 60 degrees, we see 1, 2, 1, 2. And so now we're going to create sine mountain. And the way we create sine mountain is we make a table in which the x-axis is the degrees of the unit circle ranging from 0 to 360. And then on the y-axis, marking the multiples of certain degrees, 30, 45, 60, 90, and 180. So for example, at 0 degrees, we would just say that's all marked for every single one. At 15 degrees, nothing is marked. At 30 degrees, 30 is marked. At 45 degrees, 45 is marked. Then at 60 degrees, both 30 and 60 are marked. At 90, only 30, 45, and 90, but not 60 are marked. But what emerges is the sort of mountains that emerge. And what's interesting about these mountains is that as you go up, you find that the sine magnitude increases. And as you go down, you see that the sine value decreases. So for example, at the top of the mountain is 90 and 270. And these correspond to root 4 over 2 on either side of the unit circle. If we look at 30, 150, 210, and 330, these all relate to the reference angles of 30 on the unit circle, but they also all represent root 1 over 2. And that brings us to another important rule of sine mountain, which is sine mountain is completely hollow. It only has an outer crust and not an inner core. And what separates the values in the crust from the values in the non-existent inner core is that these values can be reduced to the units above them. But that only occurs when we translate the degrees into radians. So here what we're looking at is the same sine mountain, but instead of using degrees, we use radians. And what we find is that, for example, at 60 degrees, we have 2 pi over 6 or pi over 3. And of course, pi over 3 is just the most reduced version of that same fraction. At the 30-degree level, the only things we include are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And these are what we see on the unit circle. For example, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. These are the 30-degree angles, which correspond to root 1 over 2 of the sine magnitude. But notice a pattern that emerges. Pi over 6, and then we jump to 5 pi over 6. That's a difference of 4 pi over 6. And then we jump to from 5 pi over 6 to 7 pi over 6. That's a change of 2 pi over 6. And then from 7 pi over 6 to 11 pi over 6 is a jump of 4 pi over 6. So what we see is that 4-2-4-2 pattern emerging. And we see this hold true for the 45-degree angles or the pi over 4 angles. We have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And every time we're adding 2 pi over 4. And of course, the same thing applies to the 60 degrees, the pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. The first time we're adding 1 pi, then 2 pi, then 1 pi again. And then to get from 5 pi over 3 back to pi over 3, you just add 2 pi. So how does this help us remember the values? So as you go up sine mountain, the magnitude of the sine value gets bigger. At the 30-degree reference angle level, which is the pi over 6 level, we know it's always root 1 over 2. At the 45-degree reference angle level, which is always pi over 4, we know it's root 2 over 2. At the 60-degree, which is pi over 3 level, it's root 3 over 2. And then at the top of it is the 90-degree level, which is pi over 2 or root 4 over 2.
Okay, so now we're going to use an example. Say we had to find the sine value of 7 pi over 4. The first thing we're going to do is figure out what the magnitude of that sine value is. Because we know it's a pi over 4 value, that's going to correspond to a 45-degree reference angle. And those always have a magnitude of root 2 over 2. And so next we need to figure out what quadrant 7 pi over 4 is in. And the way we're going to do that, we're going to start at pi over 4, and we're going to follow that 2, 2, 2, 2 pattern until we get to 7 pi over 4. So we go from pi over 4 to 3 pi over 4 to 5 pi over 4 to 7 pi over 4. So we start at quadrant 1, quadrant 2, quadrant 3, quadrant 4. So we know that 7 pi over 4 is in the fourth quadrant. All students take calculus, so only the cosine is positive in quadrant 4. So we know that root 2 over 2 is negative. And so now we're going to do another repetition pattern, and this one's going to be demarcated in radians, but it's only going to be of the angles that are included in a regular unit circle. This one's only going to be 30 seconds long, and I hope you enjoy it, and it's going to start in 3, 2, 1.
Okay, so we're back from the repetition pattern. And remember, the repetition pattern is designed to help you remember the placement of certain values on the unit circle. And it does that through the association between the imagery and the sound and the values themselves. So I hope it was helpful. But moving on, we're going to talk about cosine valley. And cosine valley is just the inverse relationship of sine mountain. So for example, here at the peak of sine mountain, we see it's root 4 over 2. But for cosine valley, it's root 0 over 2. And as we go down sine mountain, the sine values in magnitude get smaller and smaller and smaller. But for cosine, they get bigger and bigger and bigger. So as we go down the sine mountain, it's root 3 over 2. But for cosine, it's root 1 over 2. As we go further down, it's root 2 over 2. And it's actually the same thing for cosine. As we get to the final and first rung of sine mountain, we see it's root 1 over 2. But for cosine, it's root 3 over 2. And as we step off of sine mountain, we see the value becomes root 0 over 2. But for cosine, it becomes actually root 4 over 2.
Okay, let's do another example. Let's say we had to find the tangent on 150 degrees. Well, we know tangent's just sine over cosine. And we know 150 degrees corresponds to a 30-degree reference angle. And the 30-degree reference angles are at the bottom rung of sine mountain. We know the bottom rung of sine mountain is going to be a root 1 over 2 value. And then the opposite is true for cosine valley. The very bottom of sine mountain for cosine valley is root 4 over 2. So one rung above that is going to be root 3 over 2. And we know root 1 over 2 divided by root 3 over 2 is going to reduce down to 1 over root 3. Okay, so we know that the magnitude is going to be 1 over root 3, but we don't know if that's positive or negative. So this is where those repetition patterns are going to come in. You know 150 is going to be just above 180 on the second quadrant, and all students take calculus. And you know only sine is going to be positive in the second quadrant. This is tangent, so we know this is going to be a negative value. And if you wanted to convert this into radians, it's also very simple. We know that it's a 30-degree reference angle, and every 30-degree reference angle is some value of pi over 6. We know that the pattern is 4, 2, 4, 2. And we know that this 150 degrees is in the second quadrant. So we're going to start at pi over 6, and then we're going to do our first step in the 4, 2, 4, 2 pattern. Adding 4 is going to come to 5 pi over 6. Okay, so that's it for this video. I hope you enjoyed it, and I would really recommend people rewatch the 2 repetition patterns. Again, those are going to be the best way to instill in your memory where certain values are on the unit circle, and just having that instilled in your mind is going to be very useful for solving problems going forward in trigonometry. So thank you for watching, and take care.